Good morning. Welcome to the Zoomtown Experiment episode number 56. We're in the middle of winter. Or actually, technically, I don't even know if it's winter yet. Mid-December here in the United States in the Midwest. It was a balmy 5 degrees this morning. That's 5 degrees Fahrenheit, and I believe that's minus 15 in the rest of the world. So a pretty chilly morning we got here. But what I want to talk about today is a new feature that I've added to the Zoomie. One of a couple that are kind of coming on board here with these more current videos. And it has to do with helping the Zoomie drive in reverse. There's only 2 times the Zoomie has to go in reverse. The primary one has always been backing out of a driveway. We drive into the driveway forward, and then we must back out. And that distance would be about 8 inches or about 200 millimeters at its longest. With encoder steering, I could always get sort of close, but I never got great behavior or even acceptable behavior out of encoder steering. I don't know why. I've spent an ungodly amount of hours trying to get that to be better, and I just could not resolve it. Well, in the anytime I'm moving forward, we're following guidelines, and I've since incorporated that into the sweeping turns and a few other places. And we use TCRT 5000 photoreflective sensors. They're analog sensors. I use 2 of them, one on either side of the guideline. And then if I drift off the line, I can look at the severity of that based on the analog signal and make a proportional adjustment in velocity of one wheel or the other to steer it back on course. Works beautiful, it's smooth, and it has been very reliable. Give or take. Now I probably just jinxed myself and it'll all go to trouble land here shortly. But in reverse, I can't use that front sensor. Getting that logic to work, and then the shorter coupling distance between the sensor and the wheels, it just doesn't work, because you really got to be tricky with the sensor working backwards, and you have to steer the wrong way, so to speak, to get the sensor to go the right way. It was a disaster. And the feedback gets reversed, so on. So I've been really struggling on the new rewrite of the code to come up with a better way so that when I back out of the driveway, I am right where I need to be. I'm coming out straight in line out of the driveway. And I came up with a way to do this. Now, first I'll demonstrate to you the difference between the two. I won't show you the encoder steering in reverse. I've kind of completely removed that from the code. But we'll show you what would happen without any steering, and then with this new system that I came up with. So let's take a look on the overhead cam. Now, as you can tell, that's really bad. And yes, what I could do, I could run a calibration routine that would get both motors to turn at the same speed. And I will be incorporating that as well into my solution. But even with that solution, I never got good straight performance. One of the problems being, as we accelerate or decelerate, primarily decelerating now, the amount of variance between left and right wheel speed changes at different velocities. So at one velocity I can get it to go fine, but then as I'm decelerating, it will continue to drift off position. So that was not a workable solution, but let me show you what is. Now, to get this all to work, it took a little bit of luck, actually a lot of luck, and just the thinking back historically how things like the steering line follow steering were done with more primitive devices. What we've had in the past, before we had analog inputs and so forth, or even PWM controlled motors and that, and I believe this even goes all the way back to the early days of radio-controlled airplanes. But the common slang phrase would be, it was bang bang control. Now, as I mentioned, the TCRT 5000, I only have 3 analog inputs, and they're being used already, so I can't use that. But by adding a few resistors, I can control the output signal to be, so to speak, recognizably as a digital on or off, depending on if it sees the guideline or not. So I can have an on or off control. Well, in the old days before we had PWM control, that on or off would be when you needed to make a correction, you would turn one of the wheels off momentarily, and then that would turn the robot. Radio-controlled airplanes, and I forget the name of what we called it. It was actually before my involvement with them. But your rudder would just simply be all the way one way or straight, or it would flutter like that. And that was your control, so it was very primitive compared to today's RC control, where we got very precise and fine granular control. So that's what I went about and did a prototype circuit board and everything. I'll show you what we've got here. Yeah, it's getting really crowded up here, but I'm sure I can miniaturize that circuit board and lower it down closer to the pico as we look through here. But it just takes a couple of resistors, not really as a voltage divider per se. It's more to do with getting the LED and the reflective sensor to work in an acceptable range for voltage. It's still an analog signal, but I get it to behave in a range that works for the pico's digital input to recognize it as a digital on or a digital off. But all we got is a couple of resistors here. The inputs that I use, I'll show you on the schematic here in a minute. Here's that push button on the back of the Zoomie. I've never really found a good use for this once we get into running experiments. It's been useful up to this point, but beyond here I don't have a need for it. So that digital input, by luck, I can use. I also planned on having another Hall effect sensor. This is one of them there and one there underneath this tape. I had planned to use yet another one. So up on top, it's going to be really hard to see, but in this rat's nest of wires is another series of connectors where I can tap into that input. So I had that input and this input that I could pirate away from its original purpose and repurpose it for our new photoelectric sensors. Now, these are the two that we've been using for forward steering, and then these two are the ones that I'll be using for reverse steering. And those will be digital, and those will be working in analog output. The bracket was very simple to design and make and 3D print and all that. Ultimately, what I'll probably do is redesign this base plate of the chassis, moving the caster, the ball caster, and its mount forward, and then that way this won't stick out the back of the Zoomie, because the overall length's getting too long right now, so as it parks in a driveway, this could be sticking out into the crossroad that it came off of, so we don't want that. But that gets us the input device, a way to control it with a few resistors, and then in a moment we'll take a look at the code, and it's really quite simple. This is the schematic I've been using all along for development, and I just want to get to the digital inputs here. On the schematic, I originally had 3 set up for the A3144 Hall effect sensors, and I've repurposed one of those for one of the photoreflective sensors, TCRT 5000, and this is the input switch. So this is all being currently changed right now. So I had luck, as it would be, I had available digital inputs and a way to interface into the Pico, and I wouldn't have to go back through and have to remake the main logic board for the Zoomie. That would have been a lot of cost. So right now the cost is 2 resistors, 4 resistors, and 2 photoreflective sensors. So it's more cost, but it is working and solving the problem. But that was luck, got me the ability to get connected, the sensors connected into the system. And next up, we'll take a quick look at the programming. The logic is, frankly, just very simple because it's bang, bang, on or off. I do a little more massaging with the motor not going on and off, but that'll make sense here in a minute. What we're looking at, I'm going to zoom this out first so you get a perspective. This is a class, we'll get all the way to the top here first. Within my main program, I haven't moved it into an external library because I'm currently actively working on it a lot. But the class is, not that one, process trip instructions. And these are each type of motion I need to make. Move forward, move back, pivot turn left, right, sweep turn, cruising along, backing out of a driveway, all of that, each one of those has its own method to control that motion. And that gives me real precise control of how I want that behavior to be, as opposed to in my older system, I was really relying on a generic routine that could handle all the different things I wanted it to do. And that's when it became spaghetti code and I couldn't make sense of it as time went on. So I want to get back to where I was, and it happened to be what I'm now calling unpark. Park would be pulling into a driveway. Unpark is backing out of the driveway. So I need to find that here. Perform unpark. I'll zoom that up so it's a little easier for us to talk about. We've got a few variables at the top. My debugging is for whether I want stuff printed out while it's performing that motion. I've got a variable left speed, right speed, and that is tied to the target speeds for this particular motion. We've got some logic right here. Well, yeah, these three together. All right, okay. The first one is if the decel flag is equal to 1, the decel rate is equal to 0.8. That means it'll start to decelerate. If the now we're looking at the actual digital input of the photo switches, the left and right one. If the left one is on, the right one is off, I'll slow down almost by half the speed of the left wheel. Remember before I was referring to this as a bang bang because it's digital on or off. I don't really need to go full off because that would make it really jerky when it's backing up. And if I just change the speed, it looks a lot more smooth. If you look at it close, it is actually kind of jerking, but I'm okay with that. But this is literally how I steer with it in reverse, looking at those photoreflectives on the back of it. From that, we get our modified speed to perform steering. So then my motor control, left motor speed and right motor speed, are a function of that speed times the decel rate, if deceleration is active or not. Works out really nice. And then from here, just some more debugging stuff. I'm updating position, X and Y. That's the global position that both the scheduler looks at. Based on that information, the scheduler looks at that as to where the Zoomie physically is in the entirety of Zoomtown. Another debug print. Then we've got estimated distance to go based on current distance traveled on this motion, and then the odometer readings. And then whether we're going to stop because we've run out of distance to go, and then that just cleans up or closes out this motion, or if the distance to go is in the acceleration distance to decel, we override the motors. And every one of these motions methods operates the same way, but with different inputs that we're accounting for. So with that change, the addition of the photosensors and a few resistors, I've been able to wrangle in and control reverse steering to the point where it seems to be very reliable. Hopefully it stays that way. So with that, the next episode we'll be talking more about the various types of motions and the methods that control them, so that you understand what all has changed at this late stage of the game. So that'll wrap it up for this episode. Thanks a lot for watching. If you get a chance, please give me a thumbs up and subscribe to the channel. We got a lot more stuff coming very soon, both on the Zoomtown experiment as well as other Zoomie programming and Pico programming, etc. Thanks for watching. We'll see you next time.